If you were to look up into a clear night sky with your naked eye, what planets would you see? Technically, if conditions were right and you had very good eyesight, you would be able to see all of them at one time or another. All of them, apart from Neptune. It is the smallest of the icy giants, and also the furthest away. It's a wonder we found it at all. And it is a place of wonders. Ginormous storms that rise and fall, super fast winds that are almost supersonic, icy rings, and enigmatic moons hinting at a violent past. Of all the planets, it's the one we know the least about. But what exactly do we know about Neptune? I'm Alex McColgan and you're watching Astrum. Today in this Supercut we're going to delve into everything you could want to know about Neptune. Let's start right at the beginning with how we found Neptune in the first place. Because, unlike every other planet in the solar system, Neptune was not discovered by merely being spotted with a telescope. Its story is far more intriguing. Neptune is the only planet found through mathematical prediction. It happened in 1846, thanks to Urbain Jean-Joseph Le Verrier, a French astronomer and mathematician. Le Verrier had been examining the rotation of the then 7 planets when he noticed that something was off about Uranus. It didn't seem to be moving in line with the theories of gravity proposed by Newtonian physics. Le Verrier reasoned that the only explanation for this was that there must be a planet out beyond the orbit of Uranus that was perturbing its motion to account for this discrepancy. He did some maths and then declared that his 8th planet must exist at an exact point in the night sky. The incredible thing was, after hearing his prediction, Le Verrier's friend Johann Gottfried Galle got out a telescope, searched in that location, and sure enough discovered the planet Neptune in a single hour. It was almost exactly where Le Verrier had predicted that it would be. Triton, Neptune's biggest moon, was discovered a few days later. But since then, Neptune has been a place of mystery. It orbits at the very edge of deep space. At certain points of its year, it can even be further away from the Sun than Pluto, and the only thing found further out than Neptune are icy rocks. The Sun is only a 30th of the size in Neptune's sky, and Neptune receives roughly 1,000th of the sunlight Earth does. This dim lighting and vast distance from us means that Neptune couldn't be studied from ground-based telescopes very easily. Neptune is the 8th and furthest planet from the Sun. It orbits at about 30 astronomical units, which in other words is 4.5 billion kilometers, and means it's 30 times further from the Sun than we are. You can see why it would take a space probe using current technology 13 years to reach Neptune. 4.5 billion kilometers is a considerable distance. Because of this long orbit, it takes a huge 165 years to orbit the Sun once, which means we've only seen one Neptunian year since its discovery. All in all, our icy neighbour is certainly difficult to study. It is hard to spot, and the alternative, travelling to it with a spacecraft, is not exactly easy either. In fact, only one spacecraft has ever visited Neptune, and that craft was only able to do so by taking advantage of a rare alignment of the planets that only happens once every 175 years. That craft was Voyager 2. It wasn't until 1989, when Voyager 2 arrived, that huge amounts of information about the planet became available. On the 25th of January 1986, Voyager 2 departed Uranus and snapped this wonderful goodbye shot from 1 million kilometers as it set off to its final planetary target, Neptune, the last destination on Voyager 2's grand tour of the solar system. And after 3 years of travel at the speed of 54,000 kilometers per hour, Neptune finally came into view. Here are the first close-up images we ever received of the giant blue planet, passing only 5,000 kilometers above its north pole, the closest of any flybys. Suddenly, we could see what the planet looked like, confirmed it had planetary rings, and discovered a lot of previously unknown moons. Neptune's distance from the Sun means the average temperature in Neptune's atmosphere is very cold, -201 degrees Celsius. Its axial tilt is 28 degrees, meaning it's similar to Earth and Mars, which have 23 degrees and 25 degrees respectively. This means it has seasons similar to Earth and Mars too, the big difference being these 4 seasons last 40 Earth years each. At this moment in time, the Southern Hemisphere is experiencing spring. During this spring, the Southern Hemisphere receives more sunlight and appears brighter. This increase in brightness is actually quite noticeable, which is strange, as you would have thought that because the Sun is 900 times dimmer on Neptune than on Earth, from that distance it wouldn't make much of an impact. But even if it is only a small impact, it makes an impact nonetheless, and the increased sunlight levels in the Southern Hemisphere warm it up by about 10 degrees Celsius compared to the rest of the planet. This comparably higher temperature releases frozen methane into the stratosphere, causing its increased brightness, whereas elsewhere on the planet it remains frozen and stays deeper in the troposphere. Hydrogen was found to be the most common element in Neptune's atmosphere, making up 80% of it, although the high abundance of methane, sitting at 19%, is what gives the planet its blue appearance. Voyager 2 measured extraordinary wind speeds in Neptune's atmosphere, with the equatorial winds blowing at speeds reaching a staggering 2,160 kilometers per hour, nearly a supersonic flow. And interestingly, most wind travels retrograde to the rotation of the planet. These remarkable speeds were yet another surprise and highlighted just how dynamic and ferocious Neptune's weather systems are. This planet is home to colossal storms. When Voyager 2 passed by in 1989, it saw the Great Dark Spot, a storm about the size of Earth passing through its atmosphere. This turbulent storm seemed to be rotating counterclockwise, just like the Great Red Spot on Jupiter, and exhibited winds reaching up to 2,400 kilometers per hour, the strongest recorded in the solar system. One NASA analyst, Ken Bollinger, commented on the findings in 1989 saying, "Every day what you see is brand new. Nobody's ever seen it. It's just an incredible feeling. There's changes going on constantly on Neptune that happen very, very fast." Voyager also saw the smaller storm known as the Small Dark Spot, south of its big sibling. As Voyager 2 approached Neptune, this smaller storm changed in shade from dark to light. While our knowledge of Neptune's weather systems is limited, it would be more limited still were it not for Hubble observing them from time to time. When Hubble was launched, astronomers were curious to see the fate of these storms, to see if they were a permanent feature like Jupiter's Great Red Spot. But when Hubble was pointed at Neptune in 1999, these storms had completely disappeared, and other storms have come and gone ever since. The latest one was seen in 2015. It has lasted a few years, but it too is disappearing. While there is not enough data to speculate how these vortices develop, it could be that Neptune is like Jupiter with bands in the atmosphere. While they won't be as defined or as many as there are on Jupiter, the bands on Neptune would travel at different speeds. This could cause vortices to appear where the bands meet. Once the storm has got going, it can drift around the planet, even between the bands. But once it leaves its power source, it begins to slowly diminish, which is what we have seen. Interestingly, Hubble is the only program that can monitor these weather changes, as in most light wavelengths they are very hard to spot. Hubble, though, can probe Neptune and Uranus in the ultraviolet, making these observations possible. But why then doesn't Uranus, which is very similar in composition and size to Neptune, also have such a blustery atmosphere? Don't get me wrong, Wind speeds on Uranus are fast too, but it doesn't compete with Neptune at only 900 km per hour. Can all this only be due to interactions with the Sun and its seasons? Something else must be at play here to explain the extremes in weather. The answer may lie deep beneath Neptune's surface. I mentioned that Neptune is the furthest planet from the Sun, so you would have thought it's also the coldest. But actually, Uranus is the coldest planet in our solar system. Neptune radiates heat from within, whereas Uranus radiates hardly any excess heat at all. This could be because a large Earth-sized body crashed into Uranus billions of years ago, which depleted all of its primordial heat. Astronomers now theorize that the more active weather on Neptune might be due, in part, to this higher internal heat. What is Neptune actually made of then? Its internal structure and atmosphere is thought to be very similar to Uranus. There is a liquid mantle of water, ammonia and methane ices surrounding the core. And where the core and the mantle meet, the pressure is so great that the methane may break apart and diamonds are formed under the pressure. Likely not diamonds as you or I know, but there could be a liquid carbon ocean with solid diamond bergs floating in it, and diamonds raining down through the mantle like hailstones. This is just a theory though, as technology has only recently started to recreate such pressures. Around the core of Neptune is thought to be 7 million bar, or 700 gigapascals, which is about 7 million times the pressure of Earth's atmosphere at the surface. The two ice giants' magnetospheres also share similarities. Neptune's magnetic field is offset 47 degrees relative to its rotational axis. When Voyager 2 discovered this about Uranus, the first theory was that it had something to do with its unusual axial tilt. But then it found the same thing out about Neptune, which has a more normal axial tilt. So the current theory is that the magnetic field is either not generated in the core, but rather by an electrically conducting liquid mantle, or that the mantle deflects the magnetic field from the core, which gives it this weird offset in relation to its rotational axis. Every planet in the solar system hasn't actually got a perfectly aligned magnetic field. Even Earth's magnetic north is different from where the North Pole actually is. But it's only Uranus and Neptune that have such a tilted magnetosphere. Aurora do exist on Neptune too, but they are different from what you might expect, as they are extremely faint due to particles not getting as charged from the Sun, and because of the direction of the magnetosphere, they are mainly type B aurora, or SAR arcs. Earth gets these too, but they are not visible and you need scientific instruments to know that they are there. They could be stretching across the whole sky without you actually knowing about it. Another difference with the SAR arcs of Neptune is that they are not only found around the poles, but rather are around the mid-latitudes of the planet. However, although they are faint, we recently were able to capture images of them thanks to the powerful near-infrared detection of the James Webb Space Telescope. In March of 2025, Webb released these shimmering images of Neptune's mid-latitude aurorae, shining out across the planet. Interestingly, at the same time, Webb was able to notice a massive temperature drop in Neptune's upper atmosphere. Its temperature had dropped by hundreds of degrees since Voyager's reading in 1989, almost halving during those intervening few decades. What this means for the turbulent processes taking place within Neptune remains open for investigation, but as aurorae are harder to detect in colder temperatures, this may help explain why Neptune's aurorae remain so elusive. Zooming out from Neptune a bit, we come to its ring system. Up until 1986, scientists suspected the planet might have rings, but couldn't be certain. It turns out that, like all other gas giants, Neptune does have a ring system, although it is very faint as it is not as dense and is extremely dark in colour. If you have these rings against the black backdrop of space, and also have them be this far away from the Sun, then they are very hard to see. Intriguingly, Voyager 2 identified several partial ring structures or ring arcs within Neptune's ring system. These arcs raise questions about the mechanisms responsible for their formation and stability, since they mainly consisted of incomplete and dusty rings. There are 5 known rings in all, and they're all named after people involved in the discovery and research of Neptune. The innermost is the Gale ring, which is very faint and very wide at 2,000 kilometers. Next is the first bright ring, Le Verrier. Although it's bright, it's only 113 kilometers wide. Next, and connected, is the Lasso ring, a very faint band 4,000 kilometers across. On the edge of this ring is the Arago ring. It is slightly brighter than the Lasso ring and less than 100 kilometers wide. Lastly is the outermost and the most researched ring, the Adams ring. It is only 35 kilometers wide, but is one of the brightest rings. It is particularly interesting as it is slightly inclined and has bright arcs in it. These arcs have been quite stable since they were discovered in 1980, but usually planetary rings are uniform throughout. These arcs must be material clumping and clustering up within the ring, but the reason for this is currently unknown. Lastly, a visit to Neptune wouldn't be complete without talking about its moons. Neptune has 14 known moons, which are named after water deities in Greek mythology. 7 of these moons are regular moons, or in other words, moons that orbit along Neptune's ecliptic with very circular orbits, or orbits with very low eccentricity. After these inner regular moons, we get to the irregular moons, the first of which is Triton. I personally think it is one of the prettiest moons in our solar system, as it has amazing patterns and this burnt orange color. An irregular moon is a moon that follows an inclined, eccentric, and often retrograde orbit. This by itself is already where Triton is set apart from any other spherical moon in the solar system. It has an irregular orbit. Triton orbits clockwise around Neptune, as Neptune rotates counterclockwise, and Triton orbits at a 130-degree angle to the ecliptic of the planet, although it should be noted that its orbital eccentricity is close to 0. Its orbit is almost perfectly circular. All other large moons in the solar system are regular moons, orbiting the same direction as the rotation of their parent planet. What this heavily implies is that Triton did not form alongside Neptune, but it is in fact a captured object, specifically a captured dwarf planet. No wonder then that it is by far the biggest of Neptune's 14 moons, comprising 99.5% of the mass found in Neptune's orbit. But how big is that in scales we can relate to? Well, it is the second largest moon in relation to its parent planet, second only to Earth and its moon. While it is smaller than our moon, it orbits closer to Neptune than our moon orbits Earth, which means it appears about the same size in the sky. It is the 7th largest moon in the entire solar system, and most interestingly, it is bigger than Pluto. Pluto is often considered the king of the Kuiper belt, the biggest object that we know of that formed there, until we consider that Triton once ruled that area before Neptune captured it. So, although Triton is a moon of Neptune, it could be said that it is the biggest and most massive Kuiper belt object. Further evidence for this was found as New Horizons passed Pluto in 2015, suggesting Triton and Pluto share a near identical composition, which supports the theory that they share a common origin. Beyond Triton are 6 other irregular moons, found much further out. They are almost certainly captured objects too, with unusually eccentric orbits that take years to complete. They were probably perturbed into these weird orbits by the gravity of Triton. So, if Triton was a captured object, how did that happen? Objects need to lose momentum to be captured, otherwise they would have enough momentum to escape. Well, we can't know for sure, but the leading theory right now is that Triton was once part of a binary system, perhaps like Pluto and Charon. As Neptune approached Triton and its moon, the gravity from the encounter would have caused the binary system to fall apart, with Triton's moon being slingshot away, and Triton losing enough momentum to be captured in orbit around Neptune. I mentioned that Triton shares similar characteristics with Pluto. What exactly does that entail? Well, they both have a predominantly nitrogen ice surface with other ices mixed in, like water and carbon dioxide. It has quite a flat terrain. Its topography never varies by more than a kilometer. Although Voyager 2 did see ridges and troughs, plateaus, and ice plains. What you may find unusual though, is that it has very little in the way of craters. This implies its surface is very young and is constantly being renewed. Like Pluto, it also has some reddish patches, which is thought to be methane having reacted to UV light from the sun, producing what is known as tholins, an organic compound that has a supposedly tar-like consistency. While organic compounds do not mean life is present there, organic compounds are the basic chemicals from which life forms. Life likely couldn't exist on the surface of Triton anyway, as it's far too cold and the sun far too dim to support any life form that we can imagine. But what's interesting is what could be found under Triton's crust. Under Triton's surface is thought to be a rocky and metallic interior, which gives Triton a reasonably high density for a moon at 2 grams per centimeter cubed. Because of this, and also due to the big step up in size from the next biggest moon in the solar system, Titania, it has more mass than all the moons smaller than it in the whole solar system combined. The radioactive decay from the rocky core could be enough to heat and power convection in a subsurface ocean of water, much like what is thought to be under the surfaces of Europa, Enceladus, and some other large moons in the solar system. And just like Europa and Enceladus, cryovolcanism is an active process today on Triton. Liquid water in the mantle erupts onto the surface like lava on Earth. This is the main reason why the surface is so young. It is being actively renewed by liquid water erupting and then freezing on Triton's surface. Some very young lava plains have been identified, sparse and flat regions, yet, interestingly, with a wall that surrounds the plain. This is called a planitia, or in other words, a solidified lava lake. We also can see caldera, which is the collapse found at the center of a cryovolcano, where lava plains formed from. It is thought that the water from these eruptions would have also brought minerals from the underground oceans onto the surface, perhaps even being the source of the tholins and organic matter I mentioned earlier. If this is the case, and organic compounds are found in the subsurface ocean, it means that there's a possibility that conditions are right for life to have been able to form there. We also see long lines permeating over the surface. These are likely faults, caused either by tectonic activity or freeze-thaw weathering processes. If we look at some more of the Voyager 2 images of Triton, we can see the results of some recent eruptions. You'll notice what looks to be dark deposits on the surface, in cone or funnel-like shapes, up to 150 kilometers long. However, these smaller eruptions may not originate from the mantle itself. Voyager 2 spotted some plumes reaching 8 kilometers high, but these are thought to be because of a solid greenhouse effect within the moon's icy crust. Imagine the surface of Triton, consisting of a clear ice, which has settled on dark deposits like tholins. The sun shines through the ice, warming the darker, more absorbent tholins beneath, which sublimates a pocket of ice under the surface. As the ices sublimate, the pressure builds in the air pocket until the surface above the pocket gives way, causing an eruption. This eruption also takes the dark deposits with it, spreading them out over the surface again. If this is the case, a very similar process has been seen on Mars's poles, with carbon dioxide ices and darker deposits under the ice layer. This process can only exist because of one thing: Triton has an atmosphere, although not as thick as scientists were initially expecting. Triton's atmosphere is thin, only 0.014 millibars, about the equivalent of 80 kilometers up on Earth, although, like Pluto, this density varies through seasonal changes. Since Voyager 2's observations, Triton's atmosphere has become denser as the surface has warmed, evaporating a little of the nitrogen ices on the surface. However, when Voyager 2 passed, Triton's atmosphere was still dense enough to support weather up to 8 kilometers above its surface. In this image, you can actually see clouds on Triton. And going back to the image of the plumes, you can see the deposits from the eruptions all end up facing the same direction, due to a prevailing wind in that region of the moon. Like Pluto, Triton's atmosphere is hazy, the cause of which is thought to be hydrocarbons in the atmosphere not yet broken down into tholins by UV light from the sun. The constant depositing of organic compounds through cryovolcanism, ices evaporating and freezing again through seasonal variations, and a weather-rich, active atmosphere makes Triton a very dynamic world. All of these factors combined make it one exceptionally unusual moon. It is more a dwarf planet than a moon. But what about the others? The next biggest moon is Proteus, which is a little irregular in its shape. Normally we only see this on smaller objects like asteroids, but Proteus is actually bigger, at 400 kilometers across, than the spherical moon of Saturn, Mimas. Why it is not a sphere is explained by past collisions of things hitting the moon, leaving these massive craters which you see. The inner regular moons orbit around the rings, some acting as Sheppard moons. The outer irregular moons are all likely captured moons. Some of the irregular moons orbit prograde and others retrograde. The outermost moons of Neptune are Samathe and Netho, and are the furthest out satellite of any planet that we know of to date. They take a massive 25 years to orbit Neptune only once. This is because Neptune has a very large hill sphere, the hill sphere being the sphere in which the planet's gravity overcomes the gravity of the Sun. It has such a large hill sphere because it's already so far from the Sun. The Sun's gravity has less of an influence around Neptune than at the biggest planet, Jupiter. One of the major discoveries Hubble made about Neptune was the discovery of a new moon in 2013, which has now been named Hippocamp. Now, Hubble has discovered many moons in its time, especially around Jupiter and Saturn. But what makes Hippocamp special is that it could well be a fragment from the much larger moon of Neptune, Proteus. The 400-kilometer wide moon does indeed look like it had a tumultuous past, with giant impact craters 50 to 100 kilometers in diameter. One of these collisions likely fragmented parts of Proteus, which then fell into orbit around Neptune. Hippocamp is probably the biggest fragment, as it's an irregular 35-kilometer long object, and orbits fairly closely to the larger Proteus. Finally, there is one last object that shares a strange relationship with Neptune. Not quite a moon, but certainly something that it captured and influenced by its gravity. 2020 VN40 is a trans-Neptunian object that orbits the Sun exactly once for every 10 orbits Neptune completes. For point of reference, that means it has an orbital time around the Sun of 1,650 years, while Neptune orbits every 165 years. 2020 VN40's orbital plane is highly inclined, but its precise 10:1 ratio showcases that it is in something known as an orbital resonance with Neptune, captured in a delicate gravitational dance with the larger planet. This finding helps showcase the far-reaching influence Neptune has on the wider solar system. So, there you have it. Neptune is a fascinating world that plays an important role in the gravitational tug of war at the extreme edges of our solar system. Along with Uranus, it's the planet we know the least about, as we have only visited it once and glimpsed it with telescopes infrequently. There's still so much for us to learn about its weather, its internal structure, and its moons. Sadly, there are no confirmed missions planned to return to this azure world, and given NASA's looming financial difficulties, none are on the horizon. On the other hand, China is considering a proposal for a Neptunian probe that could be launched as soon as 2033. If it goes ahead, who knows what discoveries will be uncovered. I hope we do see a new mission go ahead. Neptune has so much more story to tell, and although it is extremely difficult to access, sometimes the best things in life are the ones that seem just out of reach. And for us, there is no planet in our solar system harder to explore than this, the final planet, Neptune. Thanks for watching. I really want to give a huge thank you to our astronauts on Patreon. It's really becoming a thriving community, and I've loved reading all your messages and comments over there. If you'd like to join in, then you can visit the link in the description to become an astronaut and bring the channel more stability than the algorithm. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.